Okay, if we have a polynomial of degree n, okay, so we're going to start 2.5 and we're going to finish 2.5 Monday and Tuesday. Okay, if we have a polynomial of degree n, then we automatically know how many zeros and how many linear factors there are. How many zeros are there? If I have a polynomial of degree n, how many zeros do we have? We have n zeros. Okay. Some of them may repeat. Some of them may be real. Some of them may be imaginary. Okay. And because there are n zeros, then we know how many factors are going to be. How many? N. Okay. Kind of like we did Tuesday on that blue worksheet, we can take a 0 and write its linear factor. If 2's are 0, x minus 2 is a linear factor. Okay. So we're going to use that over the next couple days to do some more stuff with polynomials. Okay. Before we get into, kind of mentioned it before, that synthetic division where you kind of guess numbers that you hope that are going to work and find them from there. We're going to get into that on Monday, but before we do, there's a couple other things that I want to talk about. Now, when you did your homework last night, you did quadratic formula, right? And you ended up getting some imaginary numbers for your answers? Yes? There's kind of a relationship there, right? You had like 4 plus 2i and 4 minus 2i, right? Okay. The cool thing about complex zeros, imaginary zeros, is that they come in conjugate pairs. So if a plus bi is a 0, then a minus bi is a 0. Imaginary zeros will always come in conjugate pairs. Okay. Complex zeros come in pairs. Okay, what does it mean if our 0 is imaginary? Graphically, what is happening? Shade crosses the x-axis. Okay, if our 0 is imaginary, do we have imaginary numbers on our x-axis? We do not. So if we have imaginary 0, it's not crossing the x-axis. It's doing something funky somewhere else, okay, above or below the x-axis. So if complex conjugates always come in pairs, is it possible for a 4th degree function to have all imaginary zeros? Yeah, because we could have 2 different pairs. Is it possible for a 3rd degree polynomial to have all imaginary zeros? No, if they're coming in pairs, at least one has to be real, which means we're going to have to cross the x-axis at least once, okay? And that's something that we'll continue to build on. But what I'm going to ask you to do in your homework today is take a polynomial and write out its linear factors. That's what it looks like. Okay, so we're going to make some polynomials here. We have zeros of 1, -2, and 3i. but we have a fourth degree polynomial. How do we know what our fourth zero is? They come in pairs. So if 3i is a 0, then also what? Negative 3i. They come in conjugate pairs. So our fourth degree polynomial would look like x minus 1, x minus negative 2, x minus 3i, and x minus negative 3i. Okay. Well, I want the polynomial. If I actually want the polynomial, what's the best way to go about multiplying that out? What should we start with? But you better take these two and multiply them together. They're conjugate pairs, so some special things are going to happen. All right, so let's start there. We have x times x, x times 3i, negative 3i times x, negative 3i plus times a positive 3i is a negative 9i squared. And some of you can simplify that in your head as you multiply it, and I have no problem with that. But I'm going to take my time. Okay. So we're left with x squared plus 9. Which is nice, right? Okay. Now let's be efficient about our space. Okay, some of you like to conserve space on your paper. Okay, I'm one of those people. I like to be efficient. Let's take these two and multiply them together now. And I'm just going to put my work right next to it. Okay. So when we take x minus 1 times x plus 2, we have x squared plus 2x minus x minus 2. So we get x squared plus x minus 2. Hasn't been too bad so far, right? Okay. We've multiplied two pairs of binomials. Now this one's going to take a little bit more effort because we have a trinomial to multiply to a binomial. But some of you are even starting without me, right? All we got to do is distribute through. Okay? X squared times x squared and x squared times 9. X times x squared and x times 9. And then negative 2 times x squared and negative 2 times 9. Make sure that x squared gets multiplied through, x gets multiplied through, negative 2 gets multiplied through. So we end up with, a fourth degree polynomial, x to the fourth plus x cubed. You get 7x squared plus 9x minus 18. Yeah, that's what you're getting. Now, it's a lot to ask, but you have 2 of those homework problems. So if you get your quiz done early, you can start on one or both of those homework problems. Okay? Can you handle it? Do you have a question or are you stretching? Okay. What I'll have you do is clear your desks and move your desks for the quiz. No calculator on this, okay?